So in that starter question, we notice that it says find the x-intercepts. So we just start there. How do you find intercepts again? Okay, so I asked you to have something memorized. We memorized that at the beginning of the class. If you're going to find intercepts, you make a little XY table, plug in a 0 for Y, plug in a 0 for X. That'll find the Y-intercept. And if you want to find the X-intercept, you plug in a 0 for the Y. So we're going to plug in a 0 right here. So this is going to be 0 equals 2 and then x plus 1 quantity squared minus 8. Now, if I have to solve this, I could do this a lot of different ways. We could complete the square. Well, wait a minute, that's kind of already got a perfect square. And the reason we complete the square is to make it so we can use the square root property. Can I solve this using the square root property? Sid? Sid doesn't know. Jared, can I solve this using the square root property?
If you get it by itself.
If you get the perfect square by itself, you can. So we don't need to bother setting this equal to 0, factoring everything out, because I'd have to multiply this together, all that sort of stuff. I don't need to multiply it out, so I can find out what A, B, and C are, so I can plug it into the quadratic formula. The easiest way to solve this one would be move the 8 to the other side. And like Jared was saying, continue to get it by itself. So this is going to be 4 equals x plus 1 quantity squared. Take the square root. That gives me x plus 1 over here. And what do I get over here? I get plus or minus 2. So when I solve this for x, I get x equals -1 plus or minus 2. So that's how we'd write it as one single expression. But remember, that really represents 2 x-intercepts or zeros or solutions or however you want to talk about it. So one of them is -1 plus 2, and the other one is -1 minus 2. So I've got 1 and -3. Now, what I'd like you to notice here, this is going to be a big deal, so everybody pay attention. You'll notice that if I write it this way, we've got a way of describing things where we've got -1 plus 2, -1 minus 2. Okay, those are kind of conjugates. Or in other words, they're equally spaced around -1. So I go +2, I add 2 to go in that direction, I get a 1. And here's -1 minus 2. So I start at -1, subtract 2, I'm going the other direction than I did right here, and I get -3. So these are the x-intercepts. So this actually has 2 x-intercepts. It's got one of them at 1, 0, and the other one at -3, 0. We'll worry about the y-intercept later. The instructions here were just to find the x-intercept. Okay, then it says graph and label the vertex and the intercepts. So we can already tell where the vertex is on this one. Where is it? -1, comma, -8. So I'm going to go back 1 and down 8. So that's going to put me right here. So the vertex is at -1, comma, -8. We've got an axis of symmetry here. Remember, it's always x equals the x coordinate of the vertex. So that's going to be x equals -1. And then it says label the vertex and the intercepts. Well, I've got the vertex labeled. It crosses the x-axis at 1, 0. That's right here. And at -3, 0. That's right there. So the graph looks something like this. Remember, we want to come down here, curve around, head back up, try and make it look as nice as possible. Put arrows on the end because that indicates that it continues to go up and out on both sides. Any questions there? Okay, this one was 1, 0. This one was -3, 0. So we've done all of that. And then the next question here, it says, what does the discriminant, not that we have to figure that out on this particular problem, but it might come in handy. What does the discriminant tell us about the graph of the quadratic equation? Barker. How many x-intercepts it has. Okay. So how many times it crosses the x-axis. If b squared minus 4ac is positive, then we're going to have two x-intercepts. What if it's equal to 0? One x-intercept. And what if it's negative? Okay. If it's negative, then we end up with imaginary x-intercepts, or in other words, does it cross the x-axis at all? It doesn't. Okay. So good reminder there. By the way, if we followed the pattern, does this produce the same graph? So remember, this has been multiplied by 2. That's a vertical stretch. So if I were to come over here and I went to the vertex, which is right here at -1, -8, if I go over 2, I normally go up 2 squared, but I'm going to go twice as far as that. So how far up would I go? I'd go up 8. So if I was at -8 and I went up 8, that would put me right here at 1, 0. Because over 2 puts me at +1, up 8 puts me at 0 from the vertex. Remember, everything's from the vertex on that pattern. Any questions? All right, then let's get to what we're going to study today. Okay, so today we're going to talk about how we can put things in a nice graph-friendly form. Okay, that was that vertex form. Every parabola that we've graphed so far has already been in vertex form. It already looks something like this. You could look at it and you can tell, hey, it opens up, it's been vertically stretched, it's been moved 1 to the left, because remember, those changes inside the function before it makes the shape do the opposite of what we'd think, and then it's been moved down 8. If it's in this form, it's easy to graph. If it's not in that form, so for example, let's say it's in this form right here. Okay, it's in standard form. That's not in a nice graph-friendly form, so we'd have to put it in a graph-friendly form. And that graph-friendly form has a perfect square in it. It always has a perfect square of x plus or minus some number. Helps us figure out where the vertex is. If it doesn't have that perfect square, we have to make a perfect square. So that means we're going to have to complete the square. Now, before this looks like, holy cow, another long checklist or another long procedure I need to remember how to do, this is basically the same thing as we did before when we were completing the square. But you'll notice this. When we completed the square before, the other side had a 0. Now the other side has a y or it has an f of x. We don't want to mess that up. So we want to keep everything on the same side. So when we make our adjustments, we have to adjust on the same side, and it's actually not that much more difficult than the ones we did before. So we're going to do this problem right here, and we're going to put it in a graph-friendly form. We're going to do that by completing the square. So here's the process. We start off by making room to complete the square. So I'm going to take this and I'm going to write y equals, I'm going to have 2x squared minus 12x, and then I'm going to make room. That 13 is not going to be part of our perfect square. I'm going to put that over here. It would be a good idea, this works well for most people, if you put this stuff in parentheses, because we're going to group these together. This is where we're going to make the perfect square. Okay, I can't complete the square with this being a 2. So I'm going to factor that out. Before I could divide, but I certainly wouldn't want to divide both sides because that would make this a y over 2. So I'm going to take that out. I'm left with x squared minus 6x. Tell me if I make a mistake. Plus 13. Any questions? Okay, does everybody agree that everything that's here written in black was in the original problem to begin with? It was, right? Okay, so now we're going to complete the square. That process is, once I have this as the plain old x squared, half the middle coefficient, what is that? -3. Circle that. Square that. That's going to be a 9 when I add it in here. Okay, now, I guarantee, unless you do what I tell you to, somebody's going to screw this up. They're going to make this mistake on the test. They're going to say, hey, I add 9. I got to compensate, so I'm going to add 9 over here. They're going to do something weird. Once you write this number here, grab this number that's out in front, even if it's a 1, get in the habit of drawing that line right there. Because by adding 9 to this side, inside the parentheses, I didn't really just add 9. I really added 18. Can somebody tell me why? Yeah, because there's a 9, or there's a 2 outside. So 2 times 9, that's really adding 18. You with me so far? Okay, we're almost done with the hard part. Then it gets easy. Okay, if I added 18 to this side, I would normally compensate by doing the same thing to both sides. If I adjust this side by 18, I'd adjust this side by positive 18. I can't screw up the y, so I need to compensate on the same side. So I added 18 here. How can I compensate for adding 18 if I do it on the same side? McKay?
By minusing 18 on the same side?
Yeah, let's just put a minus 18 here. So we haven't screwed up the y at all. Adding 9 inside the parentheses really added 18 to that side, and I compensate with the minus 18. So if I take a look at what I've highlighted here, does everybody agree those cancel each other out? Okay. So the change I made, I canceled out the change, so this should still represent the same parabola, same equation. Everybody good there? Draw that line, get in that habit, write the number up here, write the opposite of this number right there. Got it? Okay. So here's what the equation looks like now. Y equals 2, x minus 3 quantity squared minus 5. It's in vertex form. Okay? So let's just run through and make sure we're clear on how this process works. Make room to complete the square by moving the constant to the end and putting parentheses around those two terms. So that's what we did here. And we made sure the terms were in descending order. Factor the leading, what do we call that again? Coefficient. Factor the leading coefficient out of the two terms in parentheses, including the leading, always factor out the leading sign. We didn't have to worry about this. What's that? Oh, leading sign. So I said it right, wrote it wrong. Okay? Factor out the leading sign. We didn't have to worry about that on this one because the leading sign was a positive. But take a look at this one. That's a negative, so we're going to want to factor that out. Half times the middle coefficient, including the sign, square the result. Multiply the coefficient outside the parentheses. That's what we did here. And then figure out how to compensate. We're going to add the opposite of this number outside. So whatever this number is, we add its exact opposite. Factor and simplify to put that in vertex form. And once you get it here, now can you graph? You can. You will have a test question almost identical to this problem right here. All three of these are very good test questions. Okay? So you really need to know how to do this. Now, you'll notice that on the axes that I've got here, I don't have any tick marks. Okay? That's so we can kind of make adjustments. So let's see what we've got here. This has a vertex at 3, negative 5. So, over 3, down 5, so we're about right there. Opens which way? Opens up. So I've got my vertex at 3, negative 5, and it says label 3 points. Okay, label 3 points. So I've got this one. Let's label 1 on either side. I'm going to go over 1 and I'm going to go up 2. Thank you very much. I'm going to do the same thing on the other side. Here's my axis of symmetry. I'm going to write that what that is. And there we go. Am I done? No, because I haven't labeled. I went to the right one, that's a 4. I went up 2, that's negative 3. I went to the left one, that would change this by 1, that's going to be a 2. I went up 2, so that's again going to be a negative 3. That's following the instructions. Notice I've got arrows on both sides, I've labeled 3 points, it's shaped correctly. Yeah.
Wouldn't we want to label the X-Intercepts as well? Or no?
We'll get there. Zach's an overachiever, if you couldn't tell. He wants to outdo his older brother. Going to have to get a lot of tattoos to do that, though.
No.
Okay, any questions there? Sure? Okay, so let's do this one. F of x equals, put parentheses around these, negative 3x squared plus 12x. Put the minus 8 outside. Factor out the leading coefficient. So this is going to be, let's see, what else do I need to take out besides the coefficient?
Negative.
Take out the sign. We're going to take out the leading sign. So this is going to be x squared. That changes the sign of this. This is going to be a minus 4x. So notice everything's written in black. I really haven't changed this problem at all. I've just changed the way it looks, right? Next, half the middle coefficient, negative 2. Square that, 4. The minute I write this 4 inside, what do I draw? I draw this line indicating that I need to multiply those together to figure out how I compensate. So when I multiply the negative 3 times a 4, I get negative 12. So really, by adding 4 inside the parentheses, I've subtracted 12 from this side. How do I compensate? Add the exact opposite. So we're going to add 12 there. So these two things cancel each other out. I effectively haven't changed the problem. I've just changed the way it looks. So now it's f of x, negative 3, perfect square of x, and that number that I found right there, that's why I circle it, because I'm going to use it again. And then I've got plus 4. Any questions? Now, these take a little bit of time. Do you think I could ask you to do 15 of these on the test? Sid says yes. Okay, I'm going to put 14 of them on there.
Darn you, Sid.
Okay,
Thank you.
these take a little time, so you're probably only going to have one of these. You better do it right. But it's going to be worth several points. So, the vertex is at 2, 4. Opens down. And it's been stretched, right? Stretched by a factor of 3. So I put my vertex at 1, 2, 1, 2, 3, 4 right here. So I've got 2, 4. There's my vertex. Here's my axis of symmetry. And I'm going to switch colors so we can keep these straight. Then I'm going to go over 1 and down how far? Down 3. Over 1 and down 3. So there are my symmetric points across that axis of symmetry of x equals 2. I've labeled this point, but I don't have this correct until I label this one. Now, I've graphed a lot of these, and this isn't too hard. But it might be a good idea to figure out the coordinates of this next point that I'm going to label before I either put it above or below the x-axis, especially if you're wondering whether or not it is positive or negative. So if I go to the right one, what's my new x-coordinate? 3. If I go down 3, what's my new y-coordinate? 1. Okay, so that looks pretty good right there. That's going to be a 1. I don't even need to worry about that. If I back up 1, 1, 1. Now, again, if you did this right, this is a picture of all the points that work in the equation. So if I take this point right here and plug it into that original equation right there, it should make it true. If I plug in a 3, I will get out a positive 1. You can go ahead and try it. It'll work. Okay, are there any questions? Sure? Okay. We're going to go around the room and I'm going to have people tell me what to do. So, Elaine, what do I do first?
You take out the 2. No, you put them in parentheses.
Okay, so she says put them in parentheses. Once you practice this, it is possible to skip a couple steps. Okay, save room to complete the square. What do I do next, Christian? Christopher, sorry. Take out the negative 2. So this is an x squared. What's this? Minus 5x. Remember, when you take out the sign, it changes the sign of each one of those when you take out a negative. And that's a minus 7. Careful here. Take a good look. Next step, Jared?
Half of the 5x.
Half of the 5x. Half of just the negative 5. We really don't care about the x, just the negative 5. So what would that be? Negative 5 halves. That's the number that we put right here. We circle this. Why do we circle this again? Because we're going to need it again in just a second. Okay? Sarah Allen, what do I do with that negative 5 halves? I square it. If I square a negative, I get a positive. If I square 5, I get 25. If I square 2, I get 4. Immediately once I've written that number, what do I do, Ingrid? I times it by the negative 2. So I'm going to draw that line in there every time as a reminder. Now this looks kind of ugly. Let's see. What would we have? Negative times a positive. So that's going to be negative. Times it by 2. 2 is going to cancel with a 4. This is going to be negative 25 halves. Negative 25 halves. Emily, what do I do next? I add 25 halves out here. So these two things cancel each other out. I'm now to the point where I can write this in vertex form, but I do have a little bit of arithmetic to take care of. I've got a perfect square with that negative 2 sitting out front of x and negative 5 halves. That's why we write that down. Then I'm going to add 25 halves to negative 7. So I need to make this in halves. So that's negative 14 halves plus 25 halves. So what do I have here? 11 halves. Ugly, but that's what it is. So where is the vertex? What is it? 5 halves, comma, positive 11 halves. So that means I'm going to be over 1, 2 and a half. I'm going to be right about there. This is going to be where my axis of symmetry is. And I go up 11 and a half, or 11 halves. So that's going to be 5 and a half, right? 1, 2, 3, 4, 5 and a half. So I'm going to be right there. So that right there is my axis of symmetry. This is my vertex, 5 halves, comma, 11 halves. And then I need to go. This is by far the hardest one we've graphed, right? I need to go to the right one, and I need to go down. How far?
2.
Down 2. So I need to take 5 halves and I need to add 1 to that, and I need to go down 2. So that's going to put me at 7 halves, or in other words, that's 3 and a half. And I need to go down 2, so that would be down 4 halves. So this is going to be 7 halves. 7 halves, comma, 7 halves. Then there's another one on this other side over here. Its y-coordinate is easy. That's just going to be 7 halves. Okay, remember they're symmetric. And if I back up 1, I'd have to take 5 halves and subtract 1, or that would be 2 over 2. So if I subtract 2 over 2 from 3 over 2, sorry, 5 over 2, just gave away the answer, didn't I? 3 over 2. Ugly, ugly problem. Should I put one of those on the test?
No.
Okay. Probably not. This is how you can tell whether or not you can do this. Okay, now I'm a teacher. Keep that in mind, all right? If I gave you $100 and an hour, could you do this problem perfectly? Is it worth $100?
Yeah.
Okay.
Yeah.
If you could do this in an hour for $100, you're fine. Okay. Probably wouldn't put one that ugly on the test. Okay. But if I did, let's see. Gosh, with a degree, you're actually going to make more money. So in essence, you're being paid to learn this stuff. We'll look at it that way, right? Somehow that's just not as satisfying, is it? Okay. All right. Any questions there? Okay. Most of the time when we've graphed a parabola, we've graphed at least 3 points. Sometimes we've graphed 5 key points. And we've used the pattern, that parabola pattern, that squaring pattern, in order to find those key points. But there are times when those aren't the points we're after. We're after more specific points. And some of those points are the vertex. It's always important. We're always going to want to know where the vertex is. And then other times we want to find the X and the Y-intercept, which is what Zach was talking about earlier. It turns out that both of those are relatively easy to find. Not really easy, but relatively easy. Okay? So, if all we need to do, and this is important, that's why it's in bold. If all we need to do is find the vertex and the intercepts, then you don't need to put it in vertex form. Okay? If you're told to put it in vertex form and graph, you better put it in that form and graph it using that squaring pattern that we've been working on. Okay? If not, we can just find the vertex, the intercepts, graph those points, and we're all set to go. Now, just a quick reminder, and please have this memorized. People forget this even in my 1060 class. They forget it in 1050. They forget it in calculus. If we want to find intercepts, just make a little XY table, plug in a 0 for X, a 0 for Y. That will find the intercepts for you. Okay? Now, another quick reminder. It's always going to have a Y-intercept. It may not always have an X-intercept. Okay? So we just want to keep that in mind. So here's the next problem. We've got this function right here, and all we need to do is find the vertex and the X and the Y-intercepts, and we're going to start with this right here, and then we're going to sketch the function with those pieces of information. So how do we find the X and Y-intercepts? Little XY table, plug in a 0 for X and a 0 for Y. So if I plug in a 0, everybody watch. This is easy. This is going to find the Y-intercept. 0 here. 0 squared is 0 times 3 is still 0. 0 here. 0 times negative 12 is 0. So anything with an X in it turns into a 0. So the number sitting on the end is the Y-intercept. Just like in slope-intercept form, right? Okay, so this is going to be a 9. Now I need to figure out what the X-intercepts are. So I'm going to set this equal to 0. So this is going to be 0 equals 3x squared minus 12x plus 9. Now, this is kind of a pain, because this means I'm solving a quadratic. Remember a couple days ago we were solving quadratics to find X-intercepts? Now we're going to use those. Our techniques were, we could complete the square, we could use the square root property if it already had a perfect square, okay? Or we can factor, or we can use the quadratic formula. Which one was the easiest if it worked? Quadratic formula and completing the square. Completing the square is a pain in the butt. Okay? Quadratic formula is not too bad. Factoring, if it factors, that's the quickest way to do it. So let's do this. Take out a 3. 4x. 3. Did I make any silly mistakes? I really don't even need the 3. I could have just divided everything by 3. Okay? I kind of like it there. Multiplied to be 3, combined to be negative 4. Negative 1 and negative 3. So what's the X-intercept that comes from this factor? 1. And the X-intercept that comes from this factor? 3. So here's what I've got. 1 is one of them. Negative 3 is the other one. Oh, sorry. Positive 3, isn't it? Positive 3. Got it? Yeah.
Wouldn't you multiply the answer you got from that by 3?
You mean like here? No, first of all, because it's an X-intercept, we wouldn't multiply anything but a Y by 3, a value by 3. If you want to divide by 3, you can go ahead and do that. But this is the reason we set this equal to 0. This has to equal 0. That happens when it's 3. This has to equal 0. That happens when it's 1. When does 3 equal 0? It never does. There's never an X-intercept that comes from that. Is that all right? Anything else? Okay. Now, some of you have seen this next formula before. If you haven't, I'm going to explain really quickly where this comes from. This says we can find the vertex using this formula right here. Negative b over 2a for the x-coordinate, f of negative b over 2a for the y-coordinate. Okay? Now that can be a little bit confusing, but let me show you where this comes from. What's the quadratic formula, Elaine?
The opposite
Opposite of b.
plus or minus the square root b squared minus 4ac all over 2.
Okay, now, when we did this, we went over this. You got to have this memorized. We plug the things into this, and you'll notice something about this. Okay, this part right here, we could actually take this and write this separately. Negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. This part right here always stays the same. And whether we go to the right or to the left and what amount depends on this number right here. Whether we're adding something or subtracting something, whether it has an I, whatever it happens to be. So this right here it's like the center of the parabola. It's actually the x-coordinate of the vertex. So negative b over 2a, once it's written in standard form, tells us what the x-coordinate of the vertex is. Okay, and this just means, although it looks scary, plug it in. Take this and plug it in right there. Plug it into the function and figure out what the y-coordinate is. So let's do that right here. On this problem, what is a? 3. What's b?
Negative 12.
Negative 12. So what is opposite b over 2a? What is negative b over 2a? It's 2, isn't it? Okay, so it's 12 over 6. So we end up with 2 for an x-coordinate. Now, if I want to find the y-coordinate, here's what this means. The x-coordinate's pretty easy to find. Opposite b over 2a. This just means plug that into the function. So figure out what f of 2 is. So that's going to be 3 times 4 minus 12 times, minus 12 times 2 plus 9. So that's 12 minus 24, so that's negative 12. Plus 9 is negative 3. So where's the vertex? 2 comma negative 3. So here's what I've got. Everybody watching? I've got 1, 2, 3, 4 points. We're going to plot these 4 points, and we'll finish answering the question. Now, you'll notice again, I don't have any tick marks. So let's figure out where the vertex is, and keep in mind I've got to graph the point 0, 9. That's way up here on the y-axis. Okay, and 2, negative 3. So we don't want to make this too big. Here's the vertex. Which way does this open? Opens up. Opens up. So we're expecting to find some points up here. Let's label these. 1, 0. 3, 0. Of course, the vertex, I should label that. And then this point right here, 0, comma 9. Does that look like a parabola? Sure does. So let's go ahead and draw the parabola. Everything's turning out about like we expect. I've labeled 4 points. I've labeled the y-intercept, the 2 x-intercepts, and I've labeled the vertex. If I wanted to make a perfect graph here, I probably ought to label the axis of symmetry, x equals 2. By the way, if 2 is the x-coordinate of the vertex, if negative b over 2a is the x-coordinate of the vertex, then wouldn't the axis of symmetry also be negative b over 2a? It would. Okay, so there's a quick way to find the axis of symmetry. Okay, are there any questions? Okay, watch real quick. What does the 3 do to the shape of the graph? Vertically stretches it by 3, right? So if I go to the right one, I would normally go up 1 squared, but now I should go up 3, right? So if I go to the right one, that would change the 2 to a 3. If I go up 3 from negative 3, that would get me to 0. That points on the graph. We could have found that using the shape and the pattern produced by the squaring function. Got it? If I went back 2, I'd normally go up 4. But I've stretched it by 3, so I'm going to go up 3 times as far as 4, so that would be 12. If I started out at negative 3 and I added 12, where would I end up? I'd end up at 9. Okay? So all of those points you could actually get from that pattern that we've been spending a lot of time on. Any questions? Okay. Let's speed this up just a little bit. I'm going to do example 3, and then I want to point out a couple of other things. So, find the X and Y-intercepts. Sarah Brown, how do I do that? How do we find intercepts? Okay. We're going to plug in zeros, right? Plug in a 0 for X. That's going to find the Y-intercept. It's easy to spot. What is it? Negative 3. It's just that constant sitting out on the end if there is one. What if there's not one? Then it's 0. Okay? Then plug in a 0 for Y. So I'm going to put a 0 here. And I've got, whoops, x squared plus 6x minus 3. We could factor that other one. Does this one factor? Multiply to be negative 3, combine to be positive 6? Won't happen. So if it doesn't factor easily, what do? Quadratic. Now, let me show you why the quadratic is actually a huge advantage on problems like this. This looks like it's worse than the other one, but take a good look at this. If I solve this using the quadratic, opposite of b, so that's going to be negative 6. Plus or minus b squared, that's 36 minus 4 times a times c. That's a 1 and that's a negative 3. All over 2 times a, so all over 2. I said you should do this. Rewrite that. 36, which? Plus or minus? Plus 12, right? Now, I want you to notice something. This is opposite b. This is the discriminant stuff. This is 2a. What's negative 6 over 2? Negative 6 divided by 2 is negative 3. That's negative b over 2a. So what's the x-coordinate of the vertex? Negative 3. Okay? Now I'm going to go ahead and finish this one. Negative 6 plus or minus, this would be the square root of 48 all over 2. Square root of 48, let's see, that's going to be 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. 4 times 4 is 16. 16 times 3 is 48. Pair of 2's, pair of 2's. So this is negative 6 plus or minus 2 radical 3 all over 2, which is, take a look at this, negative 3 plus or minus radical 3.
Wait, yeah, that is a 4.
What did I do wrong?
You took out 2 pairs of 2's.
Oh, it's a 4, thanks. That's a 4, so this should be a 2. Thanks. Because I cancel a 2 out of each one of those terms. Good there? So the two answers are, the two x-intercepts are, make some space here, negative 3 plus 2 radical 3, and negative 3 minus 2 radical 3. So these are conjugates, or these are equally spaced around negative 3. So 1, 2, 3 on the negative side. Which way does this open? Opens up. Okay. The vertex would be at negative 3 comma. What does this mean again? F of negative b over 2a. It means plug that in. Okay. It means find what f of negative 3 is. So if you plug in a negative 3, let's see, we get, is that 9 or negative 9? It's 9 here, plus 6 times negative 3 minus 3. So let's see what we've got here. That's going to be 9 minus 18 minus 3. So that's going to be negative 12. So the vertex is at negative 3, negative 12. Now, It's okay that my scale isn't quite right. Let's label this point right here as the vertex. That's -3 comma -12. Crosses the y-axis where? Where does it cross the y-axis? -3, so it crosses right here. That's going to be really helpful because that means negative plus 2 radical 3 is going to be over here somewhere. And the other one's going to be symmetric over here, about right there. And there's my graph. Even though it looks crappy, how am I going to get 100% on this part of the test? Label it. There's the vertex. There's the y-intercept of 0, -3. Which x-intercept is this? It's the one with the... It's one with the plus. Because here's the axis of symmetry, -3. -3 plus, 2 radical 3, comma 0. And this one is -3 minus 2 radical 3, comma 0. Now, I realize you're not that thrilled about this. Okay? I realize this is difficult. I realize that this is kind of a long and tedious process. Okay? You will have a very difficult time passing the test if you can't do stuff like this. So again, am I going to put a whole bunch of these on the test? No. But you're going to see one, and you better be able to do it. Okay? So, finding the x and y-intercepts. Y-intercept is easy. X-intercept's kind of a pain in the butt, but it practices using the quadratic. I recommend the quadratic because this part right here tells you the x-coordinate of the vertex. It tells you the axis of symmetry. Okay? Once you have those two things, and you've got the x-coordinate of the vertex, all you need to do is plug it in and find the y-coordinate of the vertex, graph those points, connect them with a curve, extend it with arrows on the ends, label the axis of symmetry in each one of those 4 points, and you're done. Any math teacher would be thrilled if you can do this. Any math teacher would be thrilled if you could do this on a test because you'd get it all right. Okay, any questions? Okay, so let's talk about the assignment. You have bookwork, no Math Excel, you have bookwork. Math Excel is available if you want to log on there and see how it works, but I did change the instructions, okay? So I would much prefer that you do this out of the textbook and do it the way I say. Tomorrow is a Q&A day. We'll have some time to take questions, and you'll have a little bit of time to work. We will be having a quiz on this, though. So you should go home tonight, do at least 13 of these problems, if not more. If you can get it done, that would be great. Come tomorrow at the beginning of class to ask questions, and then I'm going to give you a quiz that has problems like this that we just did. Okay? So questions at the beginning, quiz toward the end. Go home and do at least 13 of these. Again, here are the instructions. For these 6 problems, put them in vertex form by completing the square. So practice the front side of the notes that we did today. For these 5, put them in vertex form, graph it, label the vertex and 2 other points. For these 6 problems, find the vertex and the intercepts, graph and label the vertex, the intercepts, and the axis of symmetry, and state the maximum and minimum and where it occurs. And I think I actually forgot to do that on the 2 of these. Do we have a max or a min? Okay. Min of -3 occurs at x equals 2. And this one, what's the min? Min is -12. It occurs at -3, at x equals -3. Okay? All right. Any questions? Okay. I do have some graph paper on the website that doesn't have any tick marks. Because these shapes and the numbers that you have to graph can be a little bit odd, maybe without tick marks would work. If you want to go to the website, whoops, and I think I showed you this before. I've actually got a bunch of graph paper here, and so chapter 8. Come on. And 2 big ones, 4 big ones, 12 of them. This one actually is probably the best. It's only, I think, 10 by 10. For most of the problems, that would be enough. It's got nice grid lines on it and stuff like that. That one's pretty good. There are some without tick marks on there, I believe. Okay? Any questions? What do you need to have done tomorrow before you come to class?
At least 13.
At least 13 of those, okay? You need to come